Function handles can be created for all kinds of functions, not just anonymous functions. You can use the @ operator to get the handle of a function. So you say @ and the function name, and that gives you the handle of the function, and then you can store that in a function handle variable. So the function name could be the name of a built-in function or a function that you've written, a user-defined function, either one. So then once you have a function handle, that gives you an alternate way of calling the function. So you can call the function by using the function handle variable and passing the input arguments, or you could use the function name and pass the input arguments. So an excellent question would be, why in the world would we ever want to do that? We already have the function name, so why do we need a function handle variable? The answer to that question is function functions. Okay, I'm about to use the word function a bazillion times, so let's start counting. Function is a function to which at least one function handle is passed. So function handles make it possible to pass functions to other functions to use, but instead of passing the name of the function, you pass its handle. So this kind of function, a function that receives a function handle as an input argument, is called a function function. The function handle that you pass can be the handle of a built-in function, or an anonymous function, or a user-defined function. Here's an example of a function function. Again, a function to which we pass at least one function handle as an input argument. In this case, I'm going to call my function fn, so that's short for function function, and that's the way I'll say it. We're going to pass two arguments. One is a vector x, and the other is a function handle. So we have two input arguments, as the function header shows, and we have one output argument. What we're going to do in the body of the function is to use the function handle to call the function and pass x as the argument to that function. And the result of that gets returned by storing it in our output argument. So again, we're passing a function handle. We're getting that function of x because using the function handle gives us an alternate way of calling the function. Now let's take a look at some examples of this on the next slides. So first what I'm going to do is I'm going to create several function handles. I'm going to create function handles for a user-defined function. So first of all, here's a function that I've defined at myfn. So I'm just using type here to display the contents. So with that function, we're passing x, and it's going to give us x cubed minus 4x plus 5, or since I've used the dot operator here, x could be a vector or it could be a scalar. So first of all, I'm going to create three function handle variables. I'll call them function handle A, function handle B, and function handle C. Function handle A is going to be the handle of this function up here that I've just created, myfn. So it's the function handle for a user-defined function. Function handle B is going to be the handle of an anonymous function that I've just created here that gives me x squared minus 3, where again x could be a scalar or a vector. And function handle C is going to be the handle of a built-in function, in this case the cosine. So I have three function handle variables. Again, I'm calling them function handle A, B, and C. So next I'm going to call the function. So first of all, I'm going to create a vector x. X in this case is going to go from 3 to 6 in steps of 0.5. And I'm going to call my function and pass to it function handle A, which is again the handle of this user-defined function up here. So by passing the handle of that function, it's just like getting this function of x cubed minus 4x plus 5. So the first value of x is 3, so we're getting 3 cubed, 27 minus 4 times 3, 27 minus 12 is 15, plus 5 gives me 20, and so forth. So I can also call my other, use my other function handles. So here I'm calling the function and passing x, again my vector x that goes from 3 to 6 in steps of 0.5, and function handle b, where we call the function handle b was the handle the anonymous function. So that's just like getting the anonymous function on every value of x. And then here I'm calling the function and passing function handle c, which was cosine of x, so that's just like getting cosine of every element in x. Or here's another example, my function passing x, and instead of a variable, just directly using the at operator here, getting the handle of sum. So that's the function is going to be just like saying sum of x, where x again goes from 3 to 6 in steps of 0.5, so adding all that together gives me 31.5. There's some related functions for functions. The function str2func is a string-to-func function. It'll receive a string, which is the name of a function, and it returns the function handle to that function. So it creates a function handle from a string. And then the reverse, func2string, converts a function handle to a string. So you might use that, for example, to put the name of the function in the title of a plot or something like that. There are some built-in functions. There's a built-in function named fplot. You pass to that a function handle and a range, and it'll plot in that range. So you don't even need to create x and y vectors. And there's a built-in function called feval that receives a function handle, again, and an argument, and it returns the execution of the function on that particular argument.